state, ma. So in solid state, see ma, how the atoms are arranged and each atom is touching with how many atoms. This is the most important discussion that we have to study in this topic. Okay, ma? Where is the position of the atom? Where atom is present? Okay, and it is touching with how many atoms? This is the most important discussion. So once you understand this one, so total solid state is dependent on this discussion only. Okay. So first of all, we will study about crystal lattice. Okay, ma? Crystal lattice. So first of all, solids you can divide into two types, no, ma? Okay. Solids you can divide into two types. One is crystalline solids. Second one is amorphous solids. Are you able to understand? So what is meant by crystalline solid and what is the difference between crystalline solids and amorphous solids? Difference in Chapandi, 12th class students, you can say this one. Clear? Crystalline solids means atoms are arranged in a particular fashion. Okay, ma? So there is particular sequence in which atoms are arranged. That type of arrangement, what you call, the type of solids, you can call them as crystalline solids. Are you able to understand? NaCl and other molecules, you can call them as crystalline solids. Then what is meant by amorphous solids, ma? Okay. So no regular arrangement of solids or atoms or molecules. This is called as amorphous solids. For example, glass. In glass, the molecules, they are not present in a particular fashion, no, ma? Wax. Wax is an example. In wax, the molecules, they are not arranged in a particular fashion. So that type of solids, you can call them as amorphous solids, and the solids in which there is a particular arrangement, that is called as crystalline solids. Okay. Now the question is, what is meant by crystal lattice? Crystal lattice means what? The arrangement of, okay, ma? Arrangement of atoms in a sequence or in a fashion. That is called as crystal lattice. Are you able to understand? And there are many types of crystal lattices. So cubical lattices are present, hexagonal lattices are present, parallelogram type of lattices are present, triagonal lattices are present, tetrahedral lattices are present. There are many types of lattices. Are you able to understand? Lattices means what? The arrangement of atoms in a particular fashion is nothing but lattice. In a crystal, atoms are arranged in a particular fashion. No? That fashion of arrangement is nothing but crystal lattice. Are you able to understand? For example, you can take this kind of arrangement. Okay? Are you able to understand, ma? So, arrangement, if it is like this. So this type of arrangement is possible, no? Are you able to understand? So just the arrangement of all the atoms in a particular structure or in a particular sequence, that is called as crystal lattice. Are you able to understand? And after crystal lattice, we study about a very important term which is called as unit cell. Okay, so what is meant by unit cell here? Unit cell is, I will write the definition here. So the smallest arrangement of atoms, clear, ma? Which repeats itself and thus, clear, ma? A crystal lattice will be formed. So that type of arrangement is called as unit cell. Now can you say what is meant by unit cell, ma? So by looking at this definition, what you have understood? Unit cell ante emani cheppandi? Unit cell means it is the smallest group of atoms or smallest arrangement of atoms which repeats itself continuously, so that finally a crystal lattice is formed. Are you able to understand? For example, consider there is some group of atoms which are arranged like this. Are you able to understand? In this one, which is the unit cell, can you say? So consider atoms are arranged like this. So these points are only atoms. So in this group of arrangement, which is the unit cell? In the unit cell edi cheppandi. Yeah? So you can say this one is one unit cell, no ma? This I can call it as one unit cell. Are you able to understand? Or each of them also you can call it as a unit cell. Why? So this type of cells, they are continuously arranged. No? So smallest arrangement which repeats itself, that is called as a unit cell. And the shape of unit cell can be anything. It can be square also, it can be triangular also, it can be rectangular also, tetrahedral also, polygon also, whatever may be the shape of the unit lattice. It should repeat itself so that crystal lattice will be formed. Are you able to understand? For example, in this room, if you see, there are how many benches? 4 rows in one bench, and here also there are 4 rows in one bench. No? So each bench is called a unit cell because it is repeating itself. No? Are you able to understand? No? Instead of that, I will do one thing. I will place one iron bench and I will place one wooden bench. Then that sequence, in that sequence, which is the unit cell? ఒక ఐరన్ బెంచ్, తర్వాత ఒక వుడన్ బెంచ్, ఆ తర్వాత ఒక ఐరన్ బెంచ్, మళ్ళీ ఒక వుడన్ బెంచ్. ఇన్ దట్ వన్ విచ్ ఇస్ ద యూనిట్ సెల్? ఏ గ్రూప్ ఆఫ్ ఐరన్ బెంచ్ అండ్ ఏ గ్రూప్ ఆఫ్ వుడ్ బెంచ్. సో బోత్ ఆఫ్ దెమ్ మేక్ వన్ యూనిట్ సెల్. అర్థమవుతుంది కదా? రెండు కలిపి ఒక యూనిట్ సెల్ని తయారు చేస్తారు బికాస్ దట్ రిపీషన్ ఈస్ రిపీటెడ్ కంటిన్యూస్లీ. సో యూనిట్ సెల్ మీన్స్ స్మాలెస్ట్ అరేంజ్మెంట్ ఆఫ్ సెల్స్ which if you repeat them continuously, finally crystal lattice should be formed. That is called as a unit cell. Are you able to understand? And we limit our discussion only up to cubic unit cells. Manam discussion enta varaku limit chestam ee class lo? Only up to cubic unit cell. What is meant by cubic unit cell? Cubic unit cell means which is present in the form of a cube. That is called as a cubic unit cell, no ma? Okay. So this is the cubic unit cell, where atoms may be present at corners, atoms may be present at the edges, atoms may be present on the faces, atoms may be present at the center of this cubic cell also. Are you able to understand? No? So we are limiting our discussion only up to cubic unit cell. Are you able to understand? So right now. So therefore what we write? We limit our discussion up to what? Up to cubic unit cell. Okay ma? So cubic unit cell means how many corners are there, can you say? Cubic unit cell lo corners ennu untayi cheppandi. How many corners will be there? 8 corners will be there. How many faces will be there? 6 faces will be there. Clear na ma? See here. So this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8. 8 corners are present. Are you able to understand? Faces, how many faces? So this is first face, this is second face, and these 2 faces, they are covered by another 4 faces. Cube ki 4 faces untai, ee vaipu malli 2 faces untai. So totally how many faces? 6 faces are present. Are you able to understand ma? So therefore cube has 8 corners and 6 faces. So this is called as a cube now, and we are limiting our discussion only up to cube only. So here length of the cube is A, breadth of the cube is A, thickness of the cube is also A only. Are you able to understand? And angle between any 2 edges is how much? 90 degrees. So we are studying only that type of units. Rendu edges madhyalo angle 90 degrees untundi kada? Are you able to understand? So therefore I can say any angle is how much? It is equal to 90 degrees. Okay. So therefore what is the volume of this unit cell ma? Volume of unit cell will be how much? Cheppandi. Volume of unit cell, A cube, volume of cube is A cube only, no? If length is A, breadth is A, and depth is also A, then volume of this unit cell is A. Are you able to understand? We are discussing about this one. Now we will study about types of unit cells ma? How many types of unit cells are possible? And we will study each of them in detail. Okay. So types of unit cell. Okay. So first one is primitive unit cell. Okay, ma? Primitive unit cell. Second one you can call it as FCC, face centered cubic. Write the full form of this one. Face centered cubic unit cell. And one more type is BCC. BCC means what? Body centered cubic cell. And one more type is ECC. ECC means what? End centered cubic cell. Okay. So these are the four types of unit cells which we will study. Are you able to understand, ma? First one is called what? First one is called as primitive unit cell, and FCC, BCC and ECC. So these are the types of unit cells which we will study. Okay. So let us have our discussion on the first one, which is called as primitive unit cell. Okay. So write down now. We are discussing about what now? We are discussing about primitive unit cell. So write the side heading, primitive unit cell. Okay. So here atoms are present only at the corners itself. Okay, ma? So in this primitive unit cell, where atoms are present? Atoms are present only at the corners. How many corners are there? 8 corners. So how many atoms will be there in this primitive unit cell? 8 atoms will be there. Are you able to understand? So shall we draw the diagram of this one? So how this one will be, Seema? So let us draw this cube first of all. This one. So here there will be one cell, one atom. Here there will be one atom. Here there will be one atom. Here there will be one atom. Another atom, another atom, another atom and another atom. So totally how many atoms, ma? 8 atoms are present. So this is called as a primitive unit cell, where atoms, they are present only at the corners only. They are not present at edges. They are not present on the face. They are not present at the center also. That is called as a primitive unit cell. Clear, ma? So next important point is okay. Second point is the corner atoms, okay, ma? They touch together. Okay, ma? What about the corner atoms? These are the corner atoms, no? So corner atoms, they always touch with each other, or we can say they are very close to each other. And this is the specialty of only primitive cell. In other cells, the corner atoms, they never touch. ఈ పాయింట్ మనం మర్చిపోకూడదు. అర్థమవుతుంది కదా? సో ఓన్లీ ఇన్ విచ్ సెల్? ఓన్లీ ఇన్ primitive cell only this is possible. Only in primitive cell only the atoms, which atoms? Corner atoms, they will touch with each other. So what is the meaning of this one, Seema? So here there is one atom, no? Actually this is not how atoms are arranged. Atoms, they are arranged like this. Are you able to understand? So this atom is in contact with the next atom. Okay. Similarly, this atom is in contact with the next atom like this. It means the atoms which are present at the corners, they will be touching with each other. And this is the property of only primitive cell. In other cells, corner atoms will never touch each other. Are you able to understand, ma? Third point is that the atoms of face diagonal do not touch each other. Do not touch each other. Okay, ma? So at the starting of the topic only I have said, no, ma, where atom is present and it is touching with what. So ప్రతి యూనిట్స్లోనూ ఇదే మనం గమనించాల్సింది. ఆటమ్స్ ఎక్కడ ఉన్నాయి, ఎవరిని టచ్ చేస్తున్నాయి. Then our discussion, half of our solid state is completed. Are you able to understand, ma? So atoms which are present at the face diagonal, they do not touch with each other. Now can you say what is meant by face diagonal? Ma? In this unit cell, in this cube, what is meant by face diagonal? Face diagonal ante? Face means what? So this is one face, no? This is one face. 6 faces are there, no? Ma? So this is one face, top face. So diagonal means what? Connecting one atom to another atom exactly in opposite direction along the diagonal. This is called as a face diagonal. So this atom and this atom, they are not touching with each other. Are you able to understand? Ma? Only corner atoms, they will touch with each other. These atoms, they will never touch with each other. Another point. Okay, ma? Fourth point is that the atoms of body diagonal, atoms of body diagonal do not touch each other. Okay? So the atoms which are present on the face diagonal also, they will not touch. Similarly, the atoms which are present on the body diagonal also, they will not touch. Now can you say, in this primitive unit cell, what is meant by body diagonal? Body diagonal ante cheppandi. Let us name this one as 1, 2, 3, 4, 5, 6, 7, 8. So draw a body line means which atom and which atom you will touch? 1 and 1 and no 1. Very good. 1 and 7 you can touch. Sima, this atom, it is present out of the board, no? Sima, here which atoms are present outside the board and which atoms are present inside the board? 1, 4, 8, 5. They are present out of the board. That's all, no? And which atoms are present inside the board? 2, 3, 6, 7. They are present inside the board. Are you able to understand? So you have to draw a diagonal from one atom which is present inside the board to the topmost corner of that atom which is present out of the board. That is called as body diagonal. అర్థమవుతుంది కదా? సో ఏ ఆటమ్కి డ్రా చేయాలి కనెక్షన్ మీరు? బోర్డు లోపల ఉన్న ఒక ఆటము లోయెస్ట్ పొజిషన్ దగ్గర ఉన్నది, బోర్డు బయట ఇంకొక ఆటం ఉంటుంది కదా, అది ఎక్కడ హైయెస్ట్ పొజిషన్లో ఉండాలి. సో దోస్ టూ ఆటమ్స్ ఇఫ్ యూ కనెక్ట్, దట్ diagonal is called as body diagonal. Are you able to understand? So therefore, now see which one and which one? 1 and 7. This is out of board, no ma? And 7 is also, 7 is present inside the board. Correct only, no? So therefore, this diagonal is called as body diagonal. So like this you can draw 4 diagonals. Are you able to understand, ma? So therefore, the atoms which are present on the body diagonal also, they do not touch with each other. So these are the properties of primitive cell. Are you able to understand, ma? Come on, make a note up to here, then we will do some calculations. This total discussion we are doing for which cell? We are doing for primitive unit cell. Okay, primitive unit cell. So in each of these unit cells we will discuss 4 concepts, clear, which are very important. And which is the first concept we are discussing? The number of atoms by mass enclosed by one unit cell. Okay, see ma, at each corner there is one atom, no? ఒక్కొక్క కార్నర్ దగ్గర ఒక్కొక్క atom ఉంది. So finally, this primitive unit cell is enclosing how many atoms by mass? Are you able to understand? See, so here there is one atom. Are you able to understand, ma? Here there is one atom, here there is one atom, here there is one atom, here another one, here another one, here another one, here another one. All these atoms, are they enclosed by this unit cell? అన్ని atoms ని ఇది enclose చేస్తుందా? Primitive unit cell, is it enclosing all the atoms? No, it is enclosing only part of atoms. ఒక పార్ట్ని మాత్రమే ఎంక్లోజ్ చేస్తుంది. Are you able to understand, ma? So ఆ పార్ట్స్ అన్ని యాడ్ చేసుకుంటూ వెళితే, if you add all those parts, finally this primitive unit cell is covering how many atoms by mass? That I want to calculate. అర్థమవుతుంది కదా? See ma, for example, if there is one atom which is present at the corner, there is one atom which is present at the corner. That corner atom can touch how many primitive unit cells? Can you say? So this is a primitive unit cell, no? There is one atom at corner. So this corner atom, it can be in contact with how many primitive unit cells? ఎన్ని primitive unit cells లో అది కాంటాక్ట్ లో ఉండగలదు?
1/8.
8 unit cells. It can be in contact with 8 unit cells. ఎలా చూద్దాం చూడండి. మళ్ళీ ఒక అద్భుతమైన డయాగ్రామ్ వేస్తాను. సేమ్. సో దిస్ ఈజ్ వన్ యూనిట్ సెల్. దిస్ ఈజ్ అనదర్ యూనిట్ సెల్. Clear Nama? So this is another unit cell, this is another unit cell. 4 unit cells are present. Are you able to understand? And at the corner there is one atom, Nama. At the corner there is one atom. This atom, it is touching all the 4 unit cells, no? But I can say that only half of the atom is touching 4 of them. So on this primitive unit cells, again I can place one more 4 unit cells, no? Half of the atom touches the above 4 unit cells, and lower half of the atom touches lowermost part of 4 unit cells. Atom ni rendu bhagalu chesinaru anukondi. If you make atom into 2 parts, upper part is touching 4 unit cells, lower part is also touching 4 unit cells. Are you able to understand? So this corner atom, it can touch how many unit cells ma? 8 unit cells it can touch. Artham avutundi kada? We are taking 4 primitive atoms, and only at the corner half మాత్రమే టచ్ అవుతుంటాయి కదా అవి. రిమైనింగ్ హాఫ్ని ఆ 4 ప్రిమిటివ్ సెల్స్ పైన మళ్ళీ 4 ప్రిమిటివ్ సెల్స్ ప్లేస్ చేయాలి మనం. సో హాఫ్ ఆఫ్ ద ఆటమ్ ఇస్ కవర్డ్ బై బాటమ్ 4, అబౌవ్ హాఫ్ ఆఫ్ ద ఆటమ్ ఇస్ కవర్డ్ బై టాప్ 4. ఓకే. సో వెన్ అన్ ఆటమ్ ఈస్ ప్రెసెంట్ అట్ ద కార్నర్, దెన్ దిస్ కార్నర్ ఆటమ్ కెన్ టచ్ 8 ప్రిమిటివ్ సెల్స్. సో దిస్ ఈస్ అ వెరీ ఇంపార్టెంట్ డిస్కషన్. ఆర్ ఏబుల్ టు అండర్స్టాండ్ మా? క్యూబ్స్ ఉంటే మనం చూపించి ఉండొచ్చు. Is it clear what is happening? These are 4 primitive cells ma. వాటిపైన మళ్ళీ 4 cells ప్లేస్ చేసినాం అనుకోండి. ఇంకా ఈ ఆటమ్ ఎక్కడ ఉంటుంది? దిస్ ఆటమ్ విల్ బి ఎగ్జాక్ట్లీ అట్ ద మిడిల్. 8 క్యూబ్స్ మధ్యలో ఉంటుంది. అంటే 8ని టచ్ చేస్తూ ఉంది కదా. ఆర్ ఏబుల్ టు అండర్స్టాండ్ మా? వీఆర్ ప్లేసింగ్ 8 atoms and this is exactly at the middle. So it is touching bottom 4 also, it is touching top 4 also. So therefore each corner atom can touch 8 primitive cells. This is one discussion. Okay, so make a note of it. So each corner atom, corner means this one, clear? This one, all of them, they are corners. Each corner atom can touch 8 primitive unit cells. Okay. Therefore in each unit cell, how much mass of atom will be present? 1/8 only, no? So its total mass is distributed in 8 unit cells. 8 unit cells lo dani mass distribute ayi untundi. Then each atom will have 1/8 of the unit cell. Are you able to understand? So therefore we write each unit cell will have 1/8 mass of each atom. Are you able to understand? For each atom, totally how many atoms are there in a primitive unit cell? 8 atoms are there because 8 corners are there. In each atom, 1/8 of mass is only present in one primitive cell. So how many atoms totally? 8 atoms. 8 into 1/8? 8 into 1/8? 1. So only 1 atomic mass is present in a primitive unit cell. By mass. Mass prakaram తీసుకుంటే 8 atoms are there, no? And each atom contributes only 1/8 mass. Total how many atoms are there? 8 atoms are there. So 8 into 1/8? Only 1. Are you able to understand? No? So like this. Let us do one more calculation. Now this is discussion about corners. Okay ma? Now if atoms they are present at edges. Okay. What is meant by edge ma? So this is a cube and one atom is present at one edge. Okay. Then this atom can touch how many cells? 4 cells. Are you able to understand? It can touch only 4 cells, no ma? So dani pakkana oka cell untundi. Here there is one more cell. So it is touching total how many cells? 2 cells. Clear, no? And above these 2 cells I place one more 2 cells. Then it will be totally surrounded, no? Are you able to understand, ma? So when atom is present at the edges, then that cell can touch 4 primitive unit cells. అర్థమవుతుందా? క్యూబ్ లాంటి బాడీ ఏదన్నా ఉందా ఇక్కడ? క్యూబ్ లాంటి బాడీ ఏది లేదు. ఓకేమా? సో దేర్ ఫోర్ అబ్బా వద్దులేరా బాబు. ఓకేమా? సో ఈచ్ ఎడ్జ్ atom can touch 4 unit cells. How many cells it can touch, ma? It can touch 4 unit cells. Okay. So therefore, how much mass will be present in each unit cell if atom is present at edges? 1 by 4. 1 by 4. Ante kada? So therefore, each unit cell will have 1 by 4th mass of each atom. Are you able to understand? Okay, ma? Next discussion. So, atom is present at the face. Where atom is present, ma? So, this is one unit cell. Okay, ma? This is one unit cell, ma? So, atom, where atom is present, this is one face, no? Atom is present on the face. Face pain undi. It is not present at the middle. It is present on the face. For example, this is the topmost face, no? So, one atom is present at the topmost face. Then this atom can touch how many unit cells?
2.
Only 2 unit cells. Are you able to understand, no? So, half of the atom is present in this unit cell. Danipan inkokati place chestunnaru anukondi. On that unit cell, if you place one more cell, it will be completely surrounded, no? Purtiga surround ayipotundi kada. So, when atom is present at the face, then this atom can touch only 2 unit cells. Okay, so therefore I know. So, each face, are you able to understand what is meant by face, ma? Face means, so consider this is a cuboid. So, it will have 6 faces, no? 1, 2, 3, 4, 5, 6 faces. Atom is present on the topmost position. This is the face. Are you able to understand? So, this battery pan inko battery place chestunnaru anukondi. Now it is touching only 2 unit cells. No? That's the meaning of it. Okay? Okay. Understood now? So therefore, when atom is present on one face, then each face touches how many primitive cells, ma? 2 primitive cubic cells. Are you able to understand? Therefore, how much mass is present in 1 by 2? Therefore, half mass of atom is present in each unit cell. Each unit cell will cover how much percentage of mass? 50%. It means only half of the atom is present in one primitive cell, another half is present in another primitive cell. Are you able to understand what is happening here? That's it. So therefore, this discussion is the most important discussion. When atom is present at corner, then that primitive cell will enclose only 1 by 8th mass. When atom is present at edges, then that primitive cell will enclose only 1 by 4th mass. When atom is present at the face, then it will enclose only half of the mass. Okay? Now similarly, when atom is present at center of the primitive cell, then center, only one, no? Okay, ma? So atom at center of primitive cell. Okay, then one atom is completely present inside unit cell. Are you able to understand, ma? Now where is the atom? Atom is present exactly at the middle of the cell. Then that one will touch only one primitive cell. మధ్యలో ఉంది కాబట్టి ఒక దాంట్లోనే ఉంటుంది. ఇదే ఒక క్యూబ్ అనుకోండి, రూమ్ మధ్యలో ఉన్నారు మీరు. ఎన్ని సెల్స్ని టచ్ చేస్తారు? మర్యాద ఒకదాన్నే టచ్ చేస్తారు, బికాస్ యు ఆర్ ప్రెసెంట్ ఇన్సైడ్ ద సెల్. ఓకే, దేర్ ఫోర్ టోటల్ మాస్ ఈస్ ఎన్క్లోజ్డ్ బై one primitive cell. Are you able to understand, ma? Therefore, for any type of cell, the formula to calculate the number of atoms is this one. So, number of atoms by mass in any cubic cell. Which is the formula, ma? So number of corner atoms divided by what? Corner atoms లో ఎంత పార్ట్ ఉంటుంది? 8th part only. That's all, no? If there is one corner atom, 1 by 8. 8 corner atoms, 8 by 8, like this. Are you able to understand? Because each corner atom will give only 1 by 8th of this mass inside the primitive cell. 1 by 8th mass మాత్రమే ఉంటుంది కదా దాంట్లో. Clear ma? Similarly, number of atoms present at edges divided by 4. Number of atoms present at face divided by 2. Number of atoms present at center divided by 1. This is the formula. Student, ఎంత beautiful గా ఉంది formula. Clear nama? Now we do the calculation for primitive unit cell. ఇప్పుడు మనము primitive unit cell గురించి మాట్లాడదాం. Okay ma? So for primitive unit cell, how many atoms are present? 8. Where they are present? Only at the corners. Edges lo levu, face lo ledu, center lo ledu. Are you able to understand ma? So therefore, number of atoms, how can I calculate? Number of atoms by mass is equals to number of atoms in corners is 8 by 8, plus number of atoms at edges 0 by 4, number of atoms at face 0 by 2, number of corners at center 0 by 1. Okay ma? So 8 by 8 is how much? 1 atom. That is my answer. Understood ma? So therefore, primitive unit cell will cover only 1 atom of mass inside its volume. తన వాల్యూమ్లో ఒక ఆటమ్ని మాత్రమే ఉంచినట్టు లెక్క. ఓకే, యాక్చువల్లీ ఇట్ ఈస్ ఎన్క్లోజింగ్ పార్షియలీ 8 atoms, బట్ బై మాస్ రేషియో ఇట్ ఈస్ ఎన్క్లోజింగ్ ఓన్లీ 1 atom. ఓకే మా? సో దిస్ ఈస్ ద మోస్ట్ ఇంపార్టెంట్ డిస్కషన్ ఇన్ the number of atoms enclosed by any kind of primitive cell. ఇక దేనికైనా ఇదే ఫార్ములానే మీరు వాడుకుంటే సరిపోతుంది. Are you able to understand? That's it. Okay. So okay ma? So we will stop our discussion up to here. We will continue in the next class. This was what we have studied until the last class. Once revise it briefly ma. So primitive unit cell means what? Cells, they are present only at the corners. How many corners are there? 8 corners are there, so 8 cells will be present. And these corner atoms, they will be touching with each other. So this corner atom touches with this one, this corner atom touches with this one, this corner atom touches with this one. So all the corner atoms which are present on the same edge, they will be touching with each other. Are you able to understand ma? So therefore, first concept what we have studied, number of atoms enclosed by unit cell by mass. Okay ma? So this unit cell will enclose how many atoms by concept of their mass. Then this was the equation which we have used, no? N corner divided by 8, n edge divided by 4, n face divided by 2, and n center divided by 1. This is what we have studied. Okay ma? So then we study the second concept number 2, which says that relation between, okay ma? Relation between atomic radius and edge length. Okay, so that relation we are going to derive now. So these relations, they are very important ma, because many times direct questions will be asked in them. 2015, 2021, are able to understand? 2019, 2004, 2006 also questions were asked from this concept. So relation between what? Relation between atomic radius and edge length. Okay, so let us draw this primitive unit cell first of all. Clear nama? So this is the unit cell nama. Okay, so what is the shape of this figure which we are drawing? This is a cubical shape, no? Cubical shape means what? Length, breadth and height, everything will be equal to what? Everything will be equal to A only. That is called as a cube nama. So therefore, volume of this cube is a cube. Okay, now let us see. So here, let us take 2 corner atoms. Here there is one atom and here there is one more atom. Are you able to understand ma? So let us draw, this is one atom. Are you able to understand ma? And this is one more atom. So these two atoms, they are touching like this. So already we discussed that in primitive unit cell, corner atoms, they will touch with each other. This is what we have studied, no? Okay, now see. So therefore, can you say, what is this distance, ma? What is this? Let us call this point as point number 1 and this point as point number 2. So distance between, okay, 1 and 2 is how much? Can you say? Distance between 1 and 2 is how much? A only, no? A is nothing but edge length. So this is equal to A. Can I say? And this A is also equal to, this distance is R, no ma? Radius of this atom is R. Radius of one more atom is another R. So A is also equal to 2R. I can write like this, no? So this is the relation between edge length and radius of the atom. In the case of which kind of atom? In the case of primitive cell. Are you able to understand? So edge length A is exactly equal to 2 times the radius of the single atom. Are you able to understand? Okay. So next concept which we write is distance between nearest atoms. So let us call it as point number I or 1. Okay, ma? Can you say what is the distance between nearest atoms, ma? Which two atoms are nearest atoms in this primitive cell? Totally 8 atoms are present, no? In out of these 2 atoms, which are the 2 atoms which are very close to each other? Huh? Definitely the atoms which are touching with each other, they are close to each other, no? ఏ ఆటమ్స్ అయితే టచ్ అవుతూ ఉంటాయో అంతకంటే క్లోజ్ ఇంకేముంటుంది, ఇంకా ఒక ఆటం ఇంకో దాంట్లోకి దూరి వెళ్ళిపోలేదు కదా. వన్ ఆటమ్ కెనాట్ ఎంటర్ ఇన్ టు అనదర్ ఆటమ్, నో? సో డెఫినెట్లీ దట్ డిస్టెన్స్ between 2 atoms which are touching with each other, that should be the least distance. Adhe kada least distance. Okay. Now these 2 atoms, are they touching? Touch avutu unnai kada. So that is the least distance. So that is nothing but A. Can I write? In terms of edge length, if I write, then that distance is nothing but A. Clear, no ma? Okay. Next see. So second question which can be asked is that next to nearest distance. Next to nearest distance. Okay. It means which is that distance which is slightly greater than smallest distance. Distance between 2 atoms I am discussing. Are you able to understand? No? What is this one? Distance between 2 nearest atoms. This is also next to nearest distance between 2 atoms. Okay. So nearest distance already we have calculated. Next nearest distance, దాని తర్వాత nearest ఏదవుతుంది? Opposite means face diagonal or body diagonal? Sima, let us call this is 1 point. Okay, point number 1. This is 2. This is 3. Okay, and this one let us call it as 5th point. This point is point number 5. Okay. So if I draw line between 1 and 3, 1 ki 3 ki line draw cheste, will it become face diagonal or body diagonal? That is face diagonal, no? Are you able to understand, no ma? So 1, 2, 3, 4, these 4 points, they are the points present on single face. Oka face pain unnai kada avi. So if I take a distance between 1 and 3, that is face diagonal. Okay? So after traveling this distance between 1 and 2 is the least distance. Next least distance is definitely distance between 1 and 3 only. Are you able to understand, Amma? So therefore, next to nearest distance is what? Next to nearest distance is, it is nothing but distance between which and which, ma? 1 and 3. Okay? Distance between 1 and 3, because both of them, they are present on the same face. The next nearest adi ayi untundi kada, cube edama meeru techindi, give me the cube. Okay. Now see ma. So where is point number 1? This is point number 1. Okay. Point number 2, point number 3, point number 4. All of them, they are present on the same face, no? First nearest distance is distance between these 2. 1 and 2. Are you able to understand, ma? Next nearest distance must be between 1 and this, which is this point 3 point. 1 and 3. So is it face diagonal or body diagonal? Face diagonal. Then which is body diagonal?
1 and 4.
If I take this point and this point, then they become body diagonal. Are you able to understand? And that is not the next nearest distance. So next nearest distance is definitely distance between 1 and 3 only. So which is called as face diagonal. Okay. Now can you say what is the length of a face diagonal? For example, if I draw this face, which face? So 1, 2, 3, 4. 1, 2, 3, 4 face I am drawing. This is the topmost face. Pine nunchi chuste naaku ee face kada kaniపించేది, and that is that face. 1, 2, 3, 4 face. Okay. Now in that 1, 2, 3, 4 face, this is the distance which I am taking, no? Okay ma? Now can you say how much will be this distance? Our distance ఎంత ఉంటుంది చెప్పండి? Root 2a, that's all. Root 2a only, no? Because distance between 1 and 2 is a. Distance between 2 and 3 is also a. Edge length a ne kada undedi. Then this becomes hypotenuse, no ma? Then hypotenuse value is equals to how much? Square root of a square plus a square is root 2 into a. Okay ma? So therefore this distance is the next to nearest distance. Are you able to understand? Okay. Third point. Third point is next to nearest distance. Now can you say what is this one? అంటే దీనికన్నా కొంచెం ఎక్కువ ఉండాలి. The distance which is slightly greater than next to next. And what is that one? That is definitely body diagonal. Are you able to understand, Nama? So or I can say distance between 1 and 5. Okay. So see in this figure, here there is point number 1. ఇక్కడ ఉంది point number 1. And where is point number 5? Point number 5 is present here. Okay. So can you say what will be this distance? ఈ distance ఎంత ఉంటుంది చెప్పండి? వెక్టర్స్లో చదివాం కదా మనం. This distance will be root 3a. Our distance ఎంత ఉంటుంది? Root 3a. Because in traveling from first point to fifth point, I have to travel one length, one width and one height also. Clear now? So square root of a square plus a square plus a square, root 3 into a. Okay, ma? So next to next distance is what here? Distance between which point and which point? Ma? First point and fifth point. Clear nama? First point is present inside the board. Board lopal undi kada adi. Fifth point is present outside the board. Are you able to understand? So that distance will be how much? And that is equals to body diagonal. Okay. And that distance will be root 3 into a. Understood now how we are calculating the distances? Distances paina clarity vachindi kada ma? Clear no? So already we have discussed where the atoms are present and atoms are touching what? Evarni touch chestunnai. This is the most important discussion in the case of primitive cells. Are you able to understand? Okay. So second concept we have completed, no? Next let us go to the third one. Okay. See here this point you should remember. 1. What is meant by 1 here? Primitive unit cell will cover how many atoms by mass? 1 atom. Primitive unit cell will cover only 1 atom by mass. Because every corner atom, it will contribute how much percentage of mass? 1/8 of the mass. Total 8 atoms are there, no? 8 into 1/8, 1 atom only. Total it is covered by a primitive unit cell. Is it clear? That's it. Okay. Third concept. Third concept is coordination number. Okay, ma? So concept number 3. Okay. Coordination number. Okay. What is meant by coordination number? So the number of atoms surrounded with shortest distance. Number of atoms surrounded with shortest distance. For example, if I take any one atom, are you able to understand ma? That atom is surrounded by how many atoms which are present at the least distance? That number is called as coordination number. And ma, we don't try to understand this one, just you try to just by heart, that is better. Are you able to understand? Because you can never find any lattice structure in the examination, no? పట్టుకొని కౌంట్ చేసుకుంటూ కూర్చోవాలంటే అయ్యే పని కాదు. సో యూ బై హార్ట్ దెమ్. క్లియర్ నమ్మా? సో ఐఎమ్ రైటింగ్ దిస్ డీటెయిల్స్ హియర్ ఫర్ primitive cubic cell. PCC means primitive cubic cell coordination number is how much? It is 6. It means each atom will be surrounded by how many atoms? 6 atoms which are present at the shortest distance. Are you able to understand? And for BCC means what? Body centered cubic unit cell. Okay, ma? For this one, the coordination number will be 8. Okay. And for FCC, face centered cubic unit cell, it will be 12. Okay, ma? So by heart these 3 values, so that will be always useful for you. Are you able to understand? So therefore, coordination number for a primitive unit cell is 6. For BCC, body centered cubic cell is 8. And for a face centered cubic cell, it is 12. Understood now? These values you should by heart. Okay. Next concept, fourth one. Fourth concept is packing fraction. Packing fraction. Okay, ma? It indicates how much percent of unit cell is occupied, okay, ma? And how much percent it is empty. Empty technical term is void. Are you able to understand, ma? So packing fraction then indicates packing fraction indicates that how much percentage of the unit cell is filled with atoms and how much percentage it is empty. That fraction we can call it as packing fraction. Are you able to understand, ma? So therefore, how can I write the equation for packing fraction? I can write like this. Okay, ma? So volume occupied by atoms by mass divided by total volume of unit cell. Total volume of unit cell. Are you able to understand, ma? So for example, if one atom is present, so you write one atom volume divided by what is the volume of a unit cell. Then you will get a fractional volume, no? That fraction is nothing but packing fraction. Are you able to understand, ma? So for example, if you take PCC, primitive unit cell, only one atom is there, no? So you write the volume of that atom divided by what is the volume of the unit cell. That fraction will give packing fraction. Are you able to understand? So same equation I can write like this also. How I can write? See, ma. I can also write same packing fraction in another terms. I can write it as packing fraction is equals to number of atoms by mass, okay, ma, multiplied by volume of each atom divided by volume of unit cell. So like this also you can write. Are you able to understand, ma? So each unit cell will have different number of atoms, no, ma? Are you able to understand? For example, a primitive unit cell, it will have only one atom by mass. Okay? Body centered, it will have 2 atoms. Face centered, it will have 4 atoms. Are you able to understand? So what is the equation I have written? Number of atoms by mass covered by the unit cell multiplied by volume of each atom. Then you will get total volume of atoms, no? Divided by what? Divided by total volume of the unit cell. Then you will get the percentage of atoms which the atoms are covering this unit cell. Enta percent, enta fraction cover avutundo vachestadi. Okay, ma? Now let us do the calculation for primitive unit cell. Okay? So primitive unit cell has how many atoms by mass, ma? Only one atom, no? So number of atoms by mass is 1. And what is the volume of each atom? Atom ఏ షేప్లో ఉంటుంది ఫస్ట్? స్ట్రైట్గా రాడ్ లాగా ఉంటుందా, కోన్ ఐస్ క్రీమ్ లాగా ఉంటుందా, ఎలా ఉంటుంది మరి? స్పెరికల్ షేప్ను. సో వాట్ ఈస్ ద వాల్యూమ్ ఆఫ్ ఎ స్పియర్? వాల్యూమ్ ఆఫ్ ఎ స్పియర్ 4/3 pi r cube. 4/3 pi r cube. So this is the volume of a sphere, no, where r is the radius of a sphere. Are you able to understand? So divided by, now can you say what is the volume of a unit cell? A cube. Volume of a unit cell is a cube. So just if you do this calculation, then you will get the packing fraction. Are you able to understand ma? Primitive unit cell covers one atom by mass. ఒక atom ఉంటుంది కదా final గా దాంట్లో one atom. Volume of each atom divided by volume of unit cell. Are you able to understand? So therefore, see ma, here R I have and here A I have. Already we calculated relation between A and R, no? What is the relation? A is equal to 2R. Substitute here. So we know that A is equal to 2R, no? So therefore packing fraction of primitive cubic unit cell is how much ma? So 4 by 3 pi R cube divided by 2R whole cube. Okay? So if I do this calculation, what I will get? R cube get cancelled. 8 will be there. So 4 pi by 8 into 3. So therefore it is pi by 6. Pi by 6 only, na? 3.14 divided by 6, slightly greater than 1 by 2. So it is approximately 0.52. Okay, ma? So which is the packing fraction? How much is the packing fraction I got? 0.52. Are you able to understand? 0.52 means what? 52% of the unit cell is completely filled. Primitive unit cell lo enta space occupy ayi untundi? 52%. Then what is the void space? 48% is the void space. Understood, Nama? So write down. Therefore what I write? Therefore, okay ma? Therefore 52% of PCC is filled and 48% is void. Okay ma? That's it. That completes our discussion on PCC, primitive unit cell gurinchina information adi. Are you able to understand ma? So therefore once let us revise primitive unit cell. How many atoms are there in primitive unit cell ma? 8 atoms are there. Where they are present? At the corners. Are they touching or not? Definitely they are touching with each other. Are you able to understand ma? So touching with each other ante anni touch ayyava aa edge length lo unnayi maatrame touch avutayi. Are you able to understand ma? So the face diagonal atoms, they do not touch. Body diagonal atoms also, they do not touch. Atoms which are only present on the edges, only they will touch. And by mass, how many atoms will be present? Only one atom will be present. And what is the packing fraction I got? Packing fraction is 0.52. And in percentage, if I want to write, it is 52% or 48% is empty. Void space means empty space. Are you able to understand? So the second type of unit cell which we are studying is BCC. What is meant by BCC? Body centered cubic cell. Okay? So listen very carefully. Sima, as usual, just like primitive cell, 8 atoms they are present at the corners. 8 corners are there, no? 8 atoms will be present. And in addition to them, there is one more atom exactly at the center. Madhyalo oka atom. Are you able to understand ma? And which atoms are touching and which atoms are not touching, that is very important. Are you able to understand? See ma, these corner atoms, they are not touching with each other. Already I said, you know, corner atoms will be touching only in the case of primitive cell only. In other type of cells, corner atoms will not be touching. So these atoms, they are not touching. But this central atom, this will be in contact with all the 8 corner atoms. How many corner atoms are there? 8. So this middle atom, which is present exactly at the middle of this volume. So this atom, it will be contact with all the 8 corner atoms which are present. Are you able to understand? So if I need to draw a diagram, I can draw a diagram like this, ma, for example. So consider here there is one atom. Okay, ma? Consider this is one atom. And consider next which face? This is the outer face, no, ma? Which one is the outer face here? Let us call this is the outer face. Or I will draw one more diagram. See, ma. So let us take this is one face. Okay. So here there is one atom. Okay. Here there is one more atom. Here there is one more atom. And here there is one more atom. These are the corner atoms. Okay. And exactly at the middle of the volume. See, ma, this atom, it is not present on the face. ఈ atom ఎక్కడ ఉంది? ఫేస్ పైన లేదు. క్యూబ్ ఏది? ఏమా ఎప్పుడే తీసేసుకున్నాను. ఓకేమా? సిమా, దిస్ మిడిల్ atom, it is not present on the face. ఫేస్ పైన లేదు. It is present inside the what you call this cell. సెల్ లోపల ఉంది అది. అర్థమవుతుంది కదా? So therefore, the atom which is present inside this cell, it is in contact with all the corner atoms. Okay? So on one face you will have 4 corners, no ma? 4 corner atoms. On the back side also you will have 4 corner atoms. So this middle atom, it is in contact with 8 corner atoms. Anni corner atoms lo adi touch lo untundi. So this is the point in which the atoms they are touching and the atoms which are not touching. Are you able to understand? That's it. Okay. So therefore, again we do again concept number 1. Okay, ma? Which is the concept number 1 here. Number of atoms by mass, okay, ma? Enclosed by body-centered cubic cell. Okay, ma? So by mass, it is enclosing how many atoms? Okay, very easily you can say, no, 8 corner atoms will make 1 atom, no? 8 corner atoms will make 1 atom, and in the middle there is one more atom. So totally 2 atoms. That's all, very easily you can say. Okay, or if you want to do with the help of calculation, you can always do. Which calculation? Number of atoms at corners divided by 8. Number of atoms at edges divided by 4. Number of atoms at where face divided by 2. Number of atoms at center divided by 1. This is the formula, no ma? Okay, so apply this formula. How many atoms are there at the corners? 8. So 8 by 8. How many atoms are there at edges? No atoms are there at the edges. 0. How many atoms are there at the face? No atoms. This is also 0. How many atoms at the center? 1. 1 divided by 1? 1. So totally 1 plus 1 is how much? 2. That's what I said, no? Okay, ma? So BCC cell, it will enclose how many atoms, ma? It will enclose 2 atoms. So this is the formula which you should remember. Okay? So corners lo 8 unnai kada. Madhyalo okati undi. Okay? So total 1 plus 1. 2 atoms will be enclosed by this body-centered cubic cell. Okay? Next concept. Concept number 2. 2. Concept number 2. What is that? Again same concept. Relation between, okay ma? Relation between radius of atom and edge length. Are you able to understand, ma? So previously we have derived a relation between edge length and radius to be A is equal to 2R, no ma? That concept I cannot use here. What is the reason? Edge atoms, they are not touching, no? Edge atoms, they are not touching. So I cannot say that 2R is equal to A, that I cannot say. Okay? Now to calculate relation between radius and edge length, which 2 atoms I have to take or which group of atoms I have to take? A atoms తీసుకోవాలి. I have to take those atoms which are touching. Touching అవుతున్నవి తీసుకుంటే సరిపోతుంది కదా. Which atoms are touching, ma? 1 corner atom, middle atom, 1 more corner atom. Body diagonal. This is not face diagonal. ఇది face diagonal కాదు, ఇది body diagonal. Why? This atom, is it present on the face? Face పైన ఉందా ఇది? No, it is present in the inside the body. Are you able to understand? So this diagonal will become body diagonal. It is not a face diagonal. So this diagram is definitely a face only. But this middle atom, is it present on the face? Face pain unda adi? Sima, for example, here there is 1 atom. Here there is 1 atom. And on the face also, if you have 1 more atom, then these 3 atoms, they are in 1 line. Ante kada? But this atom, is it present on the face? Madhyalo undi kada? It means which length you have to take? So consider this one. 1, 2, 3, 4. Okay, ma? 5, 6, 7, 8. Okay? So which 2 atoms they are touching? So this is present inside the board. Point number 6 is present outside the board. So this atom and this atom, they are touching with each other. Let us call it as point 8. Are you able to understand? So 1, 8, 6, they are in a straight line. Similarly, you can say here 8, this is also 8, let us call it as 9. Okay, ma? 8, 9 and 3. 3 na? 2. 8, 9 and 2, they are in a straight line. I can say like this. Are you able to understand, ma, what is happening? Okay. So therefore, what I say, so the atoms on body diagonal are in a straight line. are in a straight line and touching also. Touch kuda avutunnai kada? They are touching also. How can I say they are touching? Because already I said you that central atom, it is in contact with all the corner atoms, no? So definitely they are touching with each other. అర్థమవుతుందమ్మా? 3 dimensional ఆలోచించాలి. You have to use your brain in 3 dimensions. Are you able to understand? Okay. Now can you say what is the distance between this point and this point, ma? What is the distance between 1 and 6? Root 3? Yeah, root 3a. Very good. Okay, ma? So distance between 1 and 6 points, it is equals to root 3 into a. Okay? And this root 3 into a is equal to how much in terms of radius? Radius prakaram తీసుకుంటే. So from here to here r, no? Radius. Here to here 2r. Again here to here r. Totally how many? 4r. అంతే కదా? So this corner atom, it is in contact with middle atom. So that distance is r. Total diameter of middle atom is 2r. And corner atom radius is again r. So distance between one edge to another edge. Okay, ma? One corner to body diagonal, another corner. That is how much? That is exactly equal to 4r. So that is equal to 4r. Are you able to understand, ma? So therefore what is a value I got? A value is equals to 4r divided by root 3. So this is the relation between what? Body, what you call atomic radius and edge length. Okay, ma? A means edge length only, no? R means radius. This is the relation. In PCC what I got? A is equal to 2r. But here A is equals to 4r divided by root 3. That is how we calculate the relations. అర్థం అవుతున్నాయి కదా? Okay. Clear, ma? Similarly, next I calculate, okay, in the same concept, first one. So distance between nearest atoms. Can you say? What is the distance between nearest atoms, ma? Distance between nearest atoms. Which are the nearest atoms? The atoms which are touching. The atoms which are touching, they are the nearest atoms, no? So definitely I can say that one corner atom and one middle atom, they are touching with each other, no, ma? Are you able to understand? So one corner atom and one middle atom, they are touching with each other. So distance of center of the center atom and distance of center of corner atom, this distance is the shortest distance. Clear, no? Are you able to understand, ma? Now how much will be that distance? 2r. 2r is fine in terms of edge length. 2r అందరికీ తెలుసా? ఇది ఎడ్జ్ లెంత్ ప్రకారం ఎంత ఉంటుందో చెప్పండి. ఇన్ టర్మ్స్ ఆఫ్ ఎడ్జ్ లెంత్ హౌ మచ్ ఇట్ విల్ బి? Total length is root 3a, no? Then this is half of that. Half means root 3a by 2. That is the shortest distance. Okay, ma? So this is how much, ma? Root 3a divided by 2. Because length of body diagonal root 3a. This is only half of that, no? So root 3 into a. This is the shortest distance between two atoms. Are you able to understand? In PCC, these two are touching. So shortest distance was a. But now here these two, they are not touching, no? But middle one and corner atom, they are touching. So that distance is half of the body diagonal. అర్థమవుతుంది కదా? So that is root 3a by 2. Okay. So next shortest distance. Next shortest distance is how much? Next shortest distance between two atoms is nothing but the distance between the atoms which are present on the edge. Edge. Edge is a only, no, ma? This is shortest distance. Next shortest distance is this one. కొంచెం ఎక్కువ ఉండాలి. దీనికన్నా కొంచెం ఎక్కువ ఉన్నది ఇదే కదా? A. Values ప్రకారం కావాలంటే చూడండి. root 3 value is how much? root 3 value is 1.732 divided by 2 into a. Less than 1, no? Less than a. So next shortest distance means slightly greater distance, and that is definitely a only. Are you able to understand? So therefore next shortest distance is what? A. Next to next shortest distance? ఆలోచించండి. Next to next shortest distance. Root 2a only. Again why 2a by 2? Clear, Nama? See, if this is the next shortest distance, then we have phase diagonal, no? See, fourth point, it is present outside the board. Sixth point also present outside the board, no? Fourth point is present outside the board. Sixth point kuda ekkadundi outside the board. So this is the next shortest distance. This distance already I have taken, no? So this will be the next one. Distance between 4 and 6. Okay? So this is what distance between 4 and 6. And how much it will be? Root 2a. That is phase diagonal, no? Length of phase diagonal is how much? Root 2 into a. This is phase diagonal. Okay? So this is how you can calculate the values. Are you able to understand? Kavalante values calculate change. 1.732 by 2 is less than a. A is less than root 2 into a. Is it clear? So these are the distances in the case of which cell? In the case of body-centered cubic cell. Is it clear? Okay. So concept number 2 is completed. Next we go to third concept, coordination number. Okay, ma? Coordination number. Okay, ma? And coordination number already I said, you know, to by heart this one. What is the coordination number of BCC? Coordination number is 8. This you have to by heart. Are you able to understand, ma? Fourth concept. Concept number 4, packing fraction. Okay? And what is the equation of packing fraction? Already I have written in the previous concept too. So directly I am writing here. So number of atoms by mass multiplied by volume of each atom divided by volume of unit cell. Volume of unit cell. Clear? Now let us do the calculation. Okay? So this value you should remember. Remember the relation between A and R. Okay? So A is equals to 4R by root 3. And BCC is enclosing how many atoms? 2 atoms. PCC, 1 atom. BCC, 2 atoms. FCC, 4 atoms. FCC will enclose 4 atoms. Are you able to understand? Now see. So therefore packing fraction is equals to how many atoms are enclosed, ma? 2 atoms are enclosed by BCC multiplied by volume of each atom 4 by 3 pi r cube, and volume of primitive cell is a cube. That's all, no? Substitute. So write instead of a I can write 4r by 3 pi, no? Substitute there. So 2 into 4 by 3 pi r cube divided by a value is 4r divided by root 3 whole cube. Are you able to understand? Now see which are the terms which can get cancelled, ma? So 2 into 4 by 3 multiplied by pi r cube divided by 4 cube multiplied by r cube multiplied by 3 root 3. That's all, no? So r cube and r cube get cancelled. So here I will get a square. Here I will write down, ma? So therefore, do this calculation, ma? You do this calculation when you are free. Directly I am writing the answer, ma. The answer which you will get is 0.68. This is the answer which you should get. Okay, ma? 0.68. And what is meant by 0.68? 68% of the cell is completely filled, and 100 minus 68, 32% is void. That is the meaning of this one. Are you able to understand, ma? Therefore, 68% is filled and 32% is empty. Empty in the sense it is void. Okay? So these are the 4 concepts which we study in the case of body-centered cubic cell. Clear? That's it. So next one which we are studying is face-centered cubic cell. Okay? What is meant by face-centered cubic cell? See, this unit cell, this cube has how many corners? 8 corners are there. So each atom is present at 8 corners. So here 1, here 1, here 1, here 1. So totally 8 atoms are filled. Okay? And how many faces are there? Mokhal ennu unnai diniki? 6 faces are there. So at the center of each face there is 1 atom. Are you able to understand, ma? So totally 6 faces, 6 atoms, 8 corners, 8 atoms. 8 plus 4, 14 atoms are total. 8 plus 6, what did I say? 8 plus 6 totally 14 atoms will be present. Are you able to understand ma? Now the question is, which atoms will touch with each other and which atoms doesn't touch with each other? Now first of all let us see. See ma. So these thick atoms, they are the atoms which are present at the coordinates. And here we have just dotted atoms, no ma? They are the atoms which are present at the faces. So this one is present on the top face. This one is present on the side face. This is also present on the next side face. This one is present on the bottom face. This one is present on the face which is out of the board. This one is present on the face which is present inside the board. So totally 6 faces, 6 atoms. Are you able to understand ma? Now see ma. So here see the note point. Corner atoms, they never touch. Already I said, you know, corner atoms will be touching only in the case of PCC. Remaining atoms, they never touch with each other. Okay. Next is opposite phase atoms never touch. Okay. See ma, listen very carefully. So this atom and this atom, they never touch with each other. Okay. This atom is present on one face. This atom is present on the opposite face. So these two atoms, they doesn't touch with each other. Similarly, this atom and this atom, they are again on the opposite faces, no ma? They never touch on each other. Similarly, if I call this as first atom and second atom, 1 and 2 also, they never touch with each other. So చూడడానికి దగ్గరగా ఉన్నాయి, టచ్ అయ్యాను అనుకుంటారు. So 1 is present on outside of the face. So 2 is present on the inside face. So they never touch with each other. Okay ma? Then which are the atoms which touch with each other? Okay. For example, if you take this atom, the one face atom, this is in contact with all the 4 corner atoms which are present on the same face. Okay ma? So 3, 4, 5, 6, 7. Okay. 7 is in contact with 3 also, 4 also, 6 also, 5 also. Are you able to understand ma? So if you want to make a note, so draw those numbers ma, we will write so that you can understand better. 1 and 2 never touch. They are not touching with each other. Are you able to understand ma? Then 7 is in contact with, 7 is in contact with what? It is contact with 3, 4, 5 and 6. Okay ma? It means the face atom, it is in contact with corner atoms of the same face. వేరే ఫేస్ తీసుకోకూడదు మళ్ళీ మీరు, అదే ఫేస్కి సంబంధించిన కార్నర్ అటమ్స్ని టచ్ అవుతూ ఉంటుంది. సిమిలర్లీ this face atom, it will be in contact with adjacent phase atoms. Adjacent phase అంటే మని పక్కన ఇంకో ఫేజ్ ఉంటుంది కదా, వాటితో మళ్ళీ కాంటాక్ట్లో ఉంటాయి. There is one phase which is called opposite phase. Okay ma? Sima. So this is one phase. Which is the opposite phase? This is the opposite phase. So this atom and this atom, they never touch with each other. Okay. But one phase atom, it is in contact with adjacent phase atoms. How many adjacent sides are there to this one? 4 adjacent sides are there. To this phase, this is adjacent phase, no? This is also adjacent phase. This is also adjacent phase. This is also adjacent phase. So the atom which is present at one phase, it will be in contact with 1, 2, 3, 4 phase atoms. But the 5th phase atom is in the opposite side, no? With that one it will not be in contact. It means 5 phase atoms always they are in contact. 1 phase atom is not in contact. That is the point which you should understand. So this is slightly complicated when compared to previous ones. అర్థమవుతుంది కదా? Corner atoms never touch. Are you able to understand ma? Opposite phase atoms, they never touch. But the atoms which are present on the same phase, they are in contact with all the corners. Okay ma? And they are also contact with adjacent phases. One phase, it will not be in contact. Which one phase atom? That is the phase which is present on the opposite side. Are you able to understand? That's it. So that is the case in which these atoms, they are touching and the atoms which are not touching. Clear? Come on. Now after this we have completed, then what is the first concept ma? Concept number 1. 4 concepts we were discussing, no? Concept number 1. What is concept number 1? Number of atoms by mass enclosed by FCC. Are you able to understand, ma? And which is the formula? So, number of atoms enclosed formula is number of corner atoms divided by 8, number of edge atoms divided by 4, number of face atoms divided by 2, and number of center atoms divided by 1. Okay, now you can do the calculation, no? So how many corner atoms? 8. 8 by 8, 1. Edge, 0. 0 by 4. Face, 6. 6 by 2. Center, 0. 0 by 1. So 1 plus 3 is how much, ma? 4. That is my answer. So this FCC, it is equivalent to enclosing 4 atoms. So దాని లోపల మాస్ ప్రకారం తీసుకుంటే 4 ఆటంలు ఉన్నట్లు లెక్క. ఓకే, PCC 1 atom, BCC 2 atoms, FCC 4 atoms. Understood, Amma? That's it. Remember up to here, then we will continue this in the next class. So the second concept is relation between radius of atom and edge length. Okay, ma? Now see here, see ma, in this type of questions you have to take those two atoms which are touching with each other. Already cheppinanu kada. To calculate relation between radius and edge length, what you have to take? You have to take those two atoms which are touching with each other. Touch lo ఏవవుతున్నా అవి తీసుకుంటే ఇంకా ఈజీగా వస్తుంది కదా మీకు. Which atoms are touching here? See ma. So this is one face atom, no, face center atom, and this is the atom at the corner. These two definitely they are touching, no? Already we discussed, no, ma? So draw the diagram here. So therefore if I draw one face, how will be that face? Oka face draw chesta unnanu. So here there is one atom which is exactly at the center of the face. Are you able to understand, ma? And let us try a bigger one. So here there is one atom at the center of the face, and here there is one more atom which is exactly at the corner. So these two atoms, they are touching with each other. Are you able to understand, ma? And now can you say what is this distance? This distance will be how much? R. So this is one R, this is another R. So total 2R. So distance between two atoms is 2R. Are you able to understand? Now can you say if this is one face, this becomes body diagonal or face diagonal? అది ఒక ఫేస్ అనుకుంటే అది ఫేస్ డయాగ్నల్ అవుతుందా, బాడీ డయాగ్నల్ అవుతుందా? ఫేస్ డయాగ్నల్. వాట్ ఈస్ ద లెంత్ ఆఫ్ ఫేస్ డయాగ్నల్? ఫేస్ డయాగ్నల్ in terms of edge length it is root 2 into a. So this is a and this is a, no ma? Apply Pythagoras theorem. Square root of a square plus a square, root 2 2a. So bara vinali first. Are you able to understand, ma? So therefore this total face diagonal is how much? Root 2 into a. And this is also half of the face diagonal, no? This length is how much? Half of the face diagonal. So therefore can I say that 2r is equals to root 2a divided by 2. Can I say like this? Ante kada? So therefore what is a value? So therefore root 2a is equals to 4r. So a is equals to 4r divided by root 2. 4 can be written as 2 into 2 into r divided by root 2, no ma? So therefore finally how much it is? 2 root 2 into r. That is the relation between edge length and radius. అర్థమవుతుందా ఎలా చేస్తున్నాము? Are you able to understand, ma? So this is the distance between two atoms. So in between two atoms, distance means from where you have to take, ma? Distance ante ekkadi nunchi తీసుకోవాలి? From the center of the atom. Clear, no? So one radius is r, another radius is r, total 2r. And these two atoms where they are present? They are present on the face only. This is also at one corner, this is exactly at the center of the face. They are in a straight line, no? And that straight line is present where? That straight line is present on the face. And face diagonal length is root 2 into a. So this distance is exactly half of that. Are you able to understand? So therefore this is the relation between what? Radius of the atom and edge length. Understood, Nama? Okay. So next calculation I will write here. Now can you say what is the distance between nearest atoms? Distance between nearest atoms is how much, ma? Huh? In terms of edge length. Distance between two atoms is definitely 2r only because any two atoms are always touching, no? This is the distance 2r, and 2r is equals to how much? That's it. Are you able to understand, ma? So distance between nearest atoms is nothing but 2r in terms of radius, and that 2r is nothing but root 2 a by 2. So how much? A by root 2. A by root 2 only, no? A by root 2. No, ఇంతమంది ఇదేనా చెప్పింది? Then it is correct. Are you able to understand? But I was asking relation, no? So you should have said 2r is equal to a by root 2, then it is correct. Are you able to understand? Okay. So then next to next nearest distance, ma? Next to next nearest distance is how much? First of all, we write next nearest distance. This one. Same one. This is the diagram. Clear, ma? Next, one nearest distance I have calculated, a by root 2. Next nearest distance. See, my first nearest distance is nothing but the atoms which are touching. Clear, no? Next nearest distance, shall I take this atom and this atom, or this atom or this atom, or directly body diagonal I shall take? Which one shall I take? Okay. Now I have taken distance between this one and this one, no? Because these two atoms, they are touching with each other. That is the shortest distance. Next shortest distance will be how much? It will be A. That is the distance between two atoms which are present at one corner of two corners of one edge. So this is the next nearest distance. Okay. So distance between this atom and distance between this atom. Next nearest distance. First nearest distance 2r, which is equal to a by root 2. Second nearest distance is a. Okay, ma? Next one is next to next nearest distance. Next to next nearest distance is which one? Can you say? ఆ తర్వాత నెక్స్ట్ డిస్టెన్స్ ఏది ఉంటుంది? ఎక్సెల్ పంపిస్తే అమౌంట్ వేస్తాం. ఇట్లా మోసపోయిన వాళ్ళు కూడా ఉన్నారు తెలుసా మీకు? ఓకే, చెప్పండి. సో ఫస్ట్ నియరెస్ట్ డిస్టెన్స్ ఏ బై రూట్ 2. నెక్స్ట్ నియరెస్ట్ డిస్టెన్స్ ఏ. నెక్స్ట్ టు నెక్స్ట్ నియరెస్ట్ డిస్టెన్స్ సిమా. ఫస్ట్ ఆఫ్ ఆల్ దిస్ ఈజ్ ద షార్టెస్ట్ డిస్టెన్స్, ను నెక్స్ట్ దిస్ వన్. నెక్స్ట్ ఏమై ఉంటుంది? నెక్స్ట్ డిస్టెన్స్ విల్ బి డెఫినెట్లీ ఫేస్ డయాగ్నల్. ఓకే, అండ్ ఫేస్ డయాగ్నల్ ఈజ్ హౌ మచ్? ఇట్ ఈస్ 2a. ఫేస్ డయాగ్నల్ ఈజ్ root 2 into a, no? root 2 into a. Okay, first nearest distance, second nearest distance, third nearest distance. If you want to fourth nearest distance, that becomes the body diagonal. So like this you can go on calculating the distances one by one. Are you able to understand? If you want to do the calculations you can do, then also you can see that this sequence is correct. Okay? Okay, ma? So then we study about coordination number. What is meant by coordination number, ma? Concept number 3. Coordination number. What is meant by coordination number? The number of atoms surrounded to a single atom which are present at the shortest distance. Already we have discussed, you need not understand them, you just by heart them. So for FCC, the coordination number is how much? 12. It means each atom is surrounded by how many atoms which are present at the shortest distance? 12 atoms. So its coordination number is 12. Clear? Okay. So next, concept number 4. Packing fraction. Okay. What is the formula of packing fraction, ma? So, number of atoms by mass multiplied by volume of each atom divided by what, ma? Divided by volume of unit cell. Okay, that's all. Okay. So how many atoms are enclosed by FCC, ma? Chappandi. FCC encloses how many atoms by mass? 4. Already calculate చేసినాం కదా. ఏ లోకంలో ఉన్నారా మీరు? 4 atoms. And volume of each atom? 4 by 3 pi r cube. Volume of unit cell? Volume of unit cell is just a cube. That's all, no? Now already we have calculated a relation between a and r, no? What is that relation? A is equals to 2 root 2 into r. So substitute that one. Okay, ma? Already relation find out chesam kada. Just you need to substitute it. So therefore 4 into 4 by 3 pi r cube multiplied by, instead of a I have to write 2 root 2 r whole cube. Okay, now I will not do this calculation. You do this calculation. The answer which you will get is 74 or 0.74. That is what you will get. Okay, ma? So how much is the packing fraction? 0.74. It means that 74% of unit cell is occupied. If 74% is occupied, then how much percentage void? 24. 26% is void. Void means what? Empty. Okay, ma? So that is our discussion on these unit cells. Primitive cell, base, body-centered cubic cell, and face-centered cubic cell. Are you able to understand, ma? So previously, at least for every alternate year, you were getting one question on this one, ma. Okay? So be careful about this, all the 4 concepts which we have discussed. Okay? Let's fill this table, ma. So 3 types of unit cells we have taken: primitive cubic cell, body-centered cubic cell, face-centered cubic cell. So how many atoms by mass they are present at the corners, that I want to calculate. Clear, no, ma? So totally 8 corners are there, no? And at each corner we have 1 atom. And how much is the contribution of each of it? 1 by 8. So therefore 1 atom will be enclosed when atoms they are present at the corners. Okay, ma? Same is the case with the BCC also, same is the case with FCC also, because in all of them atoms they are present at corners, no? So 1 and 1. Okay, ma? Next at center, 0. Clear, na, ma? FCC also 0. BCC is 1. And 1 into 1, it is 1. Are you able to understand? This is what we have calculated, no? At the body, inside the body, only in BCC only we have 1 atom. And it is present exactly at the center, no, ma? That atom is not shared by other unit cells. Where a unit cells dani share chesukoledu kada. So total atom is present inside that unit cell only. So 1 atom is present, and how much will be contribution? 1. So 1 into 1 is 1. Okay. So next at face. So here it is 0. BCC also it is 0. But here FCC total 6 atoms are present. And when atom is present on the face, how much will be the contribution of each atom? 1 by 2. Already చదువుకున్నాం కదా. ఫేస్ పైన ఉందనుకోండి, ఆ ఫేస్ పైన ఇంకొక యూనిట్ సెల్ పెడితే 2 యూనిట్ సెల్స్ ఒక పూర్తి ఆటమ్ని కవర్ చేస్తాయి. సో దేర్ ఫోర్ 6 into 1 by 2 is how much, ma? It is equal to 3. So total number of atoms by mass is how much? Total number of atoms by mass. So here it is 1. BCC it is 1 plus 1, it is 2. It is 3 plus 1, it is equal to 4. Okay, ma? So this diagram, you should by heart this one. ఇది మీకు గుర్తుండాలి. అర్థమవుతుంది కదా? That's it. So primitive cell or simple cell, it will enclose only 1 atom. Okay, ma? Body-centered cubic cell, it will cover 2 atoms by mass. And face-centered cubic cell, it will cover 4 atoms by mass. Understood, no? And you have to remember the relation between edge length and what you call radius of the atom also. Adi kuda meeru gurtupettukovali. Are you able to understand, ma? For PCC, primitive cubic cell, what is the relation between edge length and radius, ma? A is equal to 2r. This is the relation, no? Okay. For body-centered cubic, see what is the relation? So A is equals to 4r by root 3. A is equals to 4r divided by root 3. This is the relation. For FCC, so A is equals to 2 root 2 into r. So these relations also you have to remember. Understood, no? Clear, ma? These are the relations. Next we will see about packing fractions also. Okay. So packing fraction for BCC is how much? PCC. PCC packing fraction is 0.52, or you can say 52% is full and 48% is void. Understood, Nama? For BCC, it is 0.68. It means 68% is filled and 32% is void. Understood, Nama? And for FCC, 7.74. 74% is completely filled, 26% is void. Okay, ma? These relations you should remember. Is it clear? That's it. So, how to calculate the formula of the compound by looking at which atoms are present at which position. Are you able to understand? Atoms can be present at corners, no? Virandi first. Atoms can be present at body center also. Atoms can be present at edges also. Atoms can be present at face also. Are you able to understand? So, based on that, how to calculate the molecular formula of the compound. So, depending on the structure and arrangement of atoms only, formula will be dependent on. So, a molecule formula depend avutundi. It depends on structure of that. I mean, you should have studied in chemical bonding, no? Are you able to understand? Now, see. So, the number of atoms by mass ratio of different atoms, it gives the molecular formula of the compound of different atoms. Are you able to understand, ma? So, which ratio I am supposed to take? A ratio తీసుకోవాలి నేను. I have to take that ratio, which is the ratio of the number of atoms by mass of different atoms. That's all. Okay. For example, let us see one example here. We will try to understand by taking this example. So, a compound is formed by elements X and Y. It means X is one element, Y is another element. That is the meaning of this one now. So, it crystallizes in a cubic crystal in which X atoms they are present at corners and Y atoms they are present at the face centers. So, then what is the formula of the compound? See, X atoms doesn't mean number of atoms. No. X atoms means these are the atoms of X element. Y atoms means what? These are the atoms of Y element. Okay. So, in this crystal where atoms are present, atoms they are present at corners and atoms they are present at face centers. Which type of atoms are at corners? The atoms belonging to X element, they are present at the corners. And the atoms belonging to Y element, they are at the face centers. Then what will be the formula of this crystal? This crystal formula, molecular formula, ela untundi. Clear, no? What we have written here? The number of atoms by mass of different atoms. Just that one will give the formula of the compound. Are you able to understand? Now see. So therefore, at corners, which atoms are present, ma? X type of atoms are present. That's all, no? X type of atoms are present. So how many corners will be there, ma? 8 corners will be there. And what will be the contribution by each atom? 1 by 8. Each atom will contribute to 1 by 8 when atoms they are present at the corners. Already chadukunnam kada. So 8 into 1 by 8 is how much? 1. Are you able to understand? Now let us write at faces. Okay, ma? So on the center of the face, which atoms are present? Face center lo evunnai? Y type of atoms are present. Y type of atoms are present. Okay. So at the corners, X type of atoms are present. At the faces, Y type of atoms are present. Are you able to understand, ma? And how many faces are there, ma? 6 faces will be present in a cube. And each atom at each face, it contributes how much by mass? 1 by 2. So 6 into how much? 1 by 2. 6 into 1 by 2 how much? 3. Are you able to understand? So 1 atom of X is enclosed and 3 atoms of Y is enclosed. Are you able to understand? Therefore, molecular formula of crystal is nothing but, okay, ma? X, Y, 3. This is the relation. That's all. Are you able to understand, ma? Molecular formula can be derived by just the ratio of different types of atoms by mass present at different locations. That's it. Okay. So X atoms, how many X atoms are present? 1 in that unit cell. And how many Y atoms are present? 3. So that is what is the molecular formula? XY3. That's all. Understood, no? Here, so this is one more question to find out the molecular formula of a compound. So listen carefully. So A type of atoms, they are present at corners. Okay. B type of atoms, they are present at one alternate face. What is meant by one alternate phase? How many phases are there, ma? 6 phases are there totally. In a cubic crystal, you have 6 phases. How many alternate phases are there? 3 alternate phases. Opposite phases 3 kada undedi. So itu oka opposite phase 2, itu 2, itu 2. 3 alternate phases. It means totally 6 phases. Are you able to understand? It means on only 2 opposite phases, each atom is present. On remaining 2 alternate phases, atoms are not present. That is the meaning of this one. And C type of atom exactly at the center. Are you able to understand? Now let us see. So therefore, at corners, which atoms are present? A type of atoms are present. Okay. So therefore, at corners, totally 8 will be there, and its contribution is 1 by 8. So 8 into 1 by 8 is 1 atom by mass. 1 atom by mass is enclosed by the unit cell when atoms are present at the corners. Clear, Nama? Next, at alternate phase. Alternate phase, which type of atoms are present? B type of atoms are present. Okay, ma? So alternate phase means only 2 atoms. Are you able to understand, ma? So for example, see ma, here I am drawing the diagram. Okay. So this is one phase. Here there is one atom exactly at the center. This is the exactly opposite phase. So only on one alternate phase. Not alternate phase. Are you able to understand, ma? So therefore, how many atoms totally? 2 atoms. And what is the contribution of phase atoms? 1 by 2. So 2 into 1 by 2? 1. Understood, no? Now at the center, how many atoms are there? At center only 1 atom can be present. Clear, Nama? Which type of atoms? C type of atoms. Are you able to understand? So 1 atom is present and its contribution is completely 1, so 1. So at the corners, contribution is 1. Phase contribution 1. Center contribution 1. So therefore, what is the molecular formula? Molecular formula is ABC. That is my answer. Understood, Nama? Ala calculations cheyali. Okay? Okay, ma? So, see this next question, ma. A given metal crystallizes as a cubic structure having edge length. So, what is meant by edge length, ma? Edge length is nothing but A, no? A value is 361 picometer. So, there are 4 metal atoms in unit cell. What do you understand by this one? PCC. PCC, na? No. Okay, ma? So, if there are 4 metal atoms in unit cell, means one unit cell is enclosing 4 atoms by mass. And which unit cell encloses 4 atoms by mass? FCC. So, this is an example of, so unit cell is enclosing 4 atoms by mass. That is the meaning of the statement which is given, ma. Therefore, what is the type of unit cell? Type of unit cell is FCC, face-centered cubic cell. Understood, Nama? So in PCC, 1 atom will be enclosed. In BCC, 2 atoms will be enclosed. And in FCC, 4 atoms will be enclosed. That is the meaning of the statement, no? There are 4 metal atoms in unit cell. It means inside unit cell, 4 atoms are present. Are you able to understand? It means 8 atoms, they are present at the corners. 6 atoms, they are present exactly at the center of each phase. That is the meaning of this one. Okay. Now, what is the radius of the atom? He is asking. So, therefore, in FCC, what is the relation between radius and bond length? 2r is equals to, directly relation we have derived, no? A is equals to 2 root 2 into r. This is the relation. Understood, no? Just substitute here. So, therefore, what is r value? R value is equals to A divided by 2 root 2. So, A value is 361 divided by 2 into root 2 value is 1.414. Okay, ma? So, do this calculation, whatever answer you will get, that is our answer. Okay, ma? So, therefore, less than 150. Less than 150 means 127. That is my answer. So 127 picometer. That is how we have to calculate. Understood, Nama? Table. Remembering the table which we have written, that is very important. Once you remember the table, very easily you can calculate. But you should be very careful about the language which is asked in the question. The question he is asking. So A means edge length. A is represented by edge length only. We have also studied like that only. Then the ratio of atoms in terms of edge length. In simple, body centered and face centered. Already we have written a table, Nama. In PCC, primitive cubic cell. So A is equal to 2R. This is the ratio. So therefore R is equals to, or R1 is equals to A by 2. Okay. In BCC, what is the relation? A is equals to 4R divided by root 3. So therefore what is R value? Root 3A divided by 4. Let it be R2. In PCC, what is the relation? Sorry, FCC. FCC. So therefore A is equals to 2 root 2 into R. So therefore R is equals to A by 2 root 2. Okay, this is R3. So just he is asking the ratio of R1 is to R2 is to R3. Ratio of radius only he is asking, no? So therefore do the calculation. Therefore R1 is to R2 is to R3. So how much more? So it is A by 2 is to root 3 A by 4 is to A by 2 root 2. Okay. So therefore A get cancelled, 2 also get cancelled. Okay, ma? So therefore 1 is to root 3 by 2 is to A by 1 by root 2. Okay, ma? If you want to further simplify, you can simplify by taking root 2 also. But up to here it is enough. This is the ratio. Understood, Nama? That's it.